Greetings, those who dare to discover, and welcome to Zoom Into the Void for July 2022 with the Danville Science Center. We are glad you are joining us on this early summer Tuesday for a survey of July's sky. I'm Science Ben, discoverer extraordinaire, and host for today's tour of what we see when we look up. Let's dive into discovery. We are here in the backyard of the Danville Science Center, right by the Digital Dome Theater. We are facing south, placing to the left, east to the right, west, and behind us, north. Looking in the corner, we can see it's just a minute past noon on the 12th of July, 2022. Gazing skyward, we can spot the sun slightly lower in the sky than it was this time last month. The sun reached its highest trajectory for the year on the 21st of last month. It now will gradually get lower and lower in the sky until it reaches its lowest point on December 21st, the winter solstice. Journeying through time until just the last few moments of the day. Go a few more minutes, we can spot slowly easing over the Science Center a wonderful, amazing moon rise. Tonight's moon is nearly full and it will be bright, but tomorrow night's will be the brightest and biggest of the year. Tomorrow, the moon reaches perigee, the closest point to Earth in its monthly elliptical orbit. When a full moon falls near perigee, the moon can appear as much as 30% brighter and 14% larger than usual in what's become known as a supermoon. Supermoons tend to come in series. There was a supermoon last month on the 14th, but tomorrow's will be even more brilliant. The moon will also be at aphelion, the point when it is furthest away from the sun. This will result in a particularly spectacular moon and a great time to see the features of the moon, like its famous craters or dark maria, the black beds of former lakes of lava. It will be difficult, not impossible, but difficult to spot a red light to the right of the moon and Teres, the fiery heart and the brightest star within the summer constellation, Scorpio the Scorpion, free to make an appearance now that its mortal enemy, Orion the Hunter, has descended for the season. Another red light can be found lunar left, just slightly appearing over the museum as we get a little later into the evening, just start to get into tomorrow morning. This light, however, is not a star at all, but rather the second largest planet in our system, gas giant Saturn. The visible planets are returning to the night sky after several weeks of putting on an early morning parade. Saturn will begin being visible around 11 p.m. as we move further into the month, with Jupiter and Mars following later into the night. Saturn is known as the ring planet, but it is not the only planet with rings. All four of the outer giants have them. Saturn's are just the largest and most easily viewed from Earth. The rings are composed of chunks of rock and ice, but the planet itself is composed mostly of hydrogen and helium, similar to neighboring gas giant Jupiter. It would take 9 Earths to span the diameter of Saturn, not including its rings. The planet's massive size makes it very attractive. There are some possibly 82 moons that regularly orbit the planet. While a day on Saturn lasts only 10.5 hours, it takes 29 years for it to make a single trip around the sun. Returning to tonight's sky, finally gaze a bit higher in the sky to spot 3 bright stars forming a familiar shape. Altair of Aquila the Eagle is encountered first, before reaching Bright Deneb within Cygnus the Swan. Completing our polygon is Vega, the brightest star in Lyra the Harp. Collectively, these stars form a pattern known as the Summer Triangle. This is an asterism. We've mentioned the Spring Triangle and past voyage, which can still be spotted low in the west in the early evening, but now is the time of year for the Summer asterism to shine center stage. Remember that an asterism is an unofficial pattern of stars, whereas constellations have credentials. NASA is in the process of creating new artificial asterisms in the quest to better understand Earth's weather. In addition to other events, the year 2020 experienced a massive number of tropical storms, with a record-breaking 30 named hurricanes for the season. 1/3 of those were classified as rapidly intensifying hurricanes, whose sustained winds increased by at least 35 miles per hour within a 24-hour period. Some of these storms had wind speeds increase by 100 miles per hour within 2 days. NASA and NOAA, the National Oceanic and Atmospheric Administration, utilize large satellites to monitor weather over large patches of the Earth. These satellites, however, generally measure a storm every few hours, leaving opportunities for unmonitored storms to intensify rapidly. To increase monitoring capabilities, NASA has begun the Tropics Mission. The time-resolved observations of precipitation structure and storm intensity with a constellation of small sats mission uses a series of small satellites to provide much more frequent monitoring of tropical systems. CubeSats, designed by an MIT professor and his students, are about the size of a shoebox, making them significantly more affordable to manufacture and launch than traditional weather observation satellites. Each CubeSat is equipped with a scanning microwave radiometer that measures temperature, humidity, precipitation, and cloud properties. 6 CubeSats will be launched into 3 separate orbital planes, creating an artificial asterism capable of monitoring changes in storm systems as frequently as every 21 minutes. 2 of the 6 were launched last month aboard an Astrorocket 3.3 vehicle. Unfortunately, the rocket failed to reach orbit and the satellites were lost. Next Tuesday, another attempt will launch from Cape Canaveral Space Force Station in Florida. We hope that undesirable weather does not interrupt your sky watching over the next month, and that you return for more joint discovery for next month's void, launching Tuesday, August the 9th, beginning at noon. Until then, keep discovering your world. Goodbye.